Hi guys, today I'm going to be talking about the Milankovitch cycles. Now what those are the different motions that the Earth has around the Sun. And I know that all of us know that the Earth rotates around itself on its axes and that the Earth rotates around the Sun. And some of you might know that the Sun rotates around some unknown point in space, which rotates around some other point. What is eccentricity? So eccentricity is the measure of how eccentric something is, or in other terms, how circular something is. So if something is completely circular, it has an eccentricity of 0. And the measure of eccentricity is actually what you do is you take the distance between the foci. I think I've mentioned foci before. So you take the distance between foci, and from that you divide that by the major axes of your eccentric object. So here I have an eclipse, and here's my major axis. It's the longest one, so that's why we call it major, and the shorter one is called the minor axis. I think that is. And the distance between the foci is basically, you can imagine eclipses as two circles, and the center of each circle, so it'd probably be about here and about here. So the distance between those 2 points divided by the major axes is going to be what your eccentricity is. And your eccentricity will always be a number lesser than 1, since the two foci have to be on the major axes. The reason that the eccentricity of a circle is 0 is because there's only one circle, and thus only one focal point. So the distance between the two focal points is 0. So now that you know what eccentricity is, I can throw some numbers at you, and it might make a little bit more sense. So the values for the Earth's eccentricity does change. It changes from 0.005 to 0.058. And remember again, eccentricity is the distance between the two focal points divided by the major axes. And this is not an overly fast change at all, as it is over 413,000 years, approximately. So that's an interesting fact. It is gradual change, but does change. So we go from nearly a circle, right here, to a lot more elliptical. That's a rather significant change. And it is important to note that it is a sinusoidal change. All of these motions of the Earth are sinusoidal, so they will return to a given point after a certain amount of time, and that's why we can state period, because it's sinusoidal. And a fun fact for all of you out there is that the major axis of the Earth does not change. So imagine a circle with the major axis. Is this one? We'll say it's this one. So that means that the minor axis, which would be the other one, would get smaller, and the major axis doesn't change. And most people will say that the semi-major axis of the Earth doesn't change. That's basically just taking the major axis cut in half. So the semi-major axis doesn't change. The major axis doesn't change. Next up is axial tilt. I don't really have too much to say about this one, other than the fact that the axis of the Earth's tilt does change over time. It's a sinusoidal again, so the period's 41,000 years. Most people like to quote that the tilt of the axis is 23.3 degrees. That's because it's an average of 22.1 and 24.5 degrees, which are the two extremes that the Earth is known to go at. And as you can see here, it's a measure from the arbitrary point, which is at 9 degrees, to where it is. And it'll go over, then come back, and go over and come back, and that's what gives it that sinusoidal nature. The reasons for these motions and these changes, I forgot to mention last time, in eccentricity, is because of influence of gravitational fields from larger planets. Most of it comes from Jupiter and Saturn, but it's just interactions with gravitational fields, and that's why it is sinusoidal as well, because of the periodic change of it and the time that it takes for them to go around in orbits. And this is not just to Earth, because all the other gravitational fields will interact with all the other planets, so these things do change. So eccentricity changes over the course of 413,000 years. Axial tilt is 41,000, and apsidal precession is 22,000. So all that means is that they have different years. So that means that every time it cycles will be different periods. So these can actually coincide with each other. And when they get close to coincide, it seems that we have ice ages. Well, when they reach the most extreme at the same time, it seems that we have ice ages, and these things seem to dictate a little bit climate changes. So they're hoping to gather more environmentalists or and climatologists are hoping to gather more knowledge of this and data and see if it actually does predict the climate, which is hard to predict sometimes, to say the least. So if you were interested in any of these things, go ahead and look at the Milankovitch Cycles. They are very informative, and that's what I was talking today. I only covered 3 of them. There are more. Most people actually says 5. So yeah, look at that if you're interested, and if not, don't. I'll see you guys next time. Have a good one.